Japan's largest underwater volcano has just cracked open the Earth. This startling event is a reminder of the powerful forces shaping our planet. But what does this eruption mean in the broader context of global geological activities? Why should we pay attention to an event happening deep beneath the ocean's surface? Join us as we explore the eruption's implications and unravel the dynamic nature of Earth's geology. Japan's underwater volcanic activity took a dramatic turn when the largest volcano beneath the sea cracked open the Earth, leading to a remarkable and unexpected event. This eruption wasn't just any ordinary geological occurrence, it was a spectacular display of nature's power, leading to the formation of a new island. Imagine the ocean's surface breaking open as lava surged upwards, creating land where there was none before. The event was captured on video, showing the violent birth of the island, a sight both awe-inspiring and alarming. From the scientific perspective, this eruption was a manifestation of intense geological processes at work. Beneath the sea, immense pressure had been building up within the Earth's crust. When it became too much to contain, it resulted in this volcanic eruption. But what causes such immense pressure to build up beneath the Earth's surface, and how does it lead to the dramatic formation of new land? This natural pressure cooker scenario, where magma forces its way up through the Earth's crust, is a fundamental process in geology. It's how new land is often formed, especially in volcanic regions like Japan, which sits on the volatile Pacific Ring of Fire. The global scientific community was quick to react to this significant event. Researchers and geologists from all over the world turned their attention to this new development. Their primary concern was understanding the potential environmental impact and the implications for future geological activity in the region. International bodies also showed concern, recognizing that such powerful natural events don't just have local, but global ramifications. There was a unanimous sense of urgency in studying and understanding this eruption, as it provided a unique opportunity to learn more about underwater volcanoes and their impact on Earth's geology. Japan's relationship with volcanic activity is as old as the land itself, deeply ingrained in its natural history. Located on the Pacific Ring of Fire, a hotspot for seismic activity, Japan is no stranger to the forces of nature that shape and reshape the Earth. This region is notorious for its high concentration of volcanoes, both above and underwater. The recent eruption of Japan's largest underwater volcano is just the latest chapter in this long history. It's a reminder of the constant geological activity happening beneath the ocean's surface, often unnoticed until it dramatically makes itself known. The formation of the new island due to this eruption is a fascinating process, showcasing nature's ability to create and destroy. This event, occurring in the Ogasawara Island chain off the coast of Japan, was triggered when an unnamed undersea volcano, located about half a mile off the southern coast of Iwo Jima, also known as Ioto, began erupting on October 21, 2023. The underwater volcano's eruption spewed out magma, which rapidly cooled and solidified upon contact with the ocean water. As smoke, ash, and earth sand were released into the air, this accumulation of volcanic material broke the surface, resulting in the birth of a new island. This new landmass, initially about 328 feet in diameter and rising about 66 feet above the sea, emerged from the ocean with a diameter of about 100 meters. However, the future of this island is uncertain. Such islands can be short-lived, eroding away or even vanishing entirely due to ongoing volcanic activity or the relentless pounding of ocean waves. The ecological impact of this new island, initially barren, is also a point of great interest. It could eventually support life, serving as a natural laboratory for scientists studying ecological succession and how life colonizes new environments. Intriguingly, this island chain has a history of similar geological activities. For instance, in 2013, another volcanic eruption in this region resulted in the formation of a new island, which measured around 200 meters in diameter. The recent eruption is particularly significant as it marks the first time since 1986 that magma has erupted in this part of the Pacific Ocean. However, the future of this newly formed island remains uncertain. Islands like this typically face the challenges of the oceanic environment, leading to their submersion or erosion, often within a short period post-formation, due to the harsh conditions of the ocean. The eruption also involved phreatic eruptions, a phenomenon where water interacts with extremely hot magma, lava, or rocks, causing explosive reactions. Such eruptions instantaneously solidify volcanic material from the seabed. Due to the frequent volcanic activities, Iwo Jima has been experiencing significant geological changes, including a rise of over 3.3 feet each year, making it one of the fastest-growing caldera volcanoes in the world. The significance of Japan's latest volcanic event goes beyond the immediate spectacle. It ties into a long history of geological activity in the region and around the world. The formation of the new island is a striking example of the natural processes that continuously shape our planet. The emergence of a new island from an underwater volcanic eruption presents an extraordinary opportunity to observe the formation of an ecosystem from scratch. Initially, this new landmass is barren and devoid of life. However, nature has a way of filling in empty spaces. Seeds carried by birds or the wind can take root, pioneering species of plants can establish themselves, and eventually, a new ecosystem can emerge. The process begins with hardy plants and microorganisms that can survive in harsh, nutrient-poor conditions. These early colonizers play a crucial role, gradually altering the environment to make it more hospitable for other species. Over time, as soil forms and vegetation takes hold, the island can support a wider variety of life, from insects to birds and possibly even mammals, depending on its size and location. This natural process of colonization and ecological succession offers invaluable insights for ecologists and biologists. It's like watching the accelerated evolution of an ecosystem, providing a living laboratory for studying ecological principles and the interplay between different species and their environment. While the formation of a new island is a fascinating natural phenomenon, it also raises several environmental concerns. The primary worry is the impact of the volcanic activity itself, which can release harmful gases and ash into the atmosphere and the surrounding ocean. This can lead to local pollution, affecting air and water quality and potentially harming marine life. Another concern is the stability and permanence of the island. If the island erodes quickly or is unstable, it could disrupt marine habitats. The shifting sands and rocks might destroy nascent ecosystems before they have a chance to fully establish themselves. However, there are also potential positive impacts. A new island can create new habitats, offering refuge and breeding grounds for marine birds and other wildlife. It can also contribute to biodiversity, especially if it becomes a stopping point for migratory species. On a broader scale, volcanic eruptions and the formation of new islands can have implications for global climate patterns. Volcanic eruptions release significant amounts of carbon dioxide, a greenhouse gas, which can contribute to global warming. However, they also emit sulfur dioxide, which can have a cooling effect on the Earth's atmosphere by reflecting sunlight away from the planet. The dual impact of volcanic eruptions on climate is complex and can vary greatly depending on the scale of the eruption and the specific gases released. In the case of this underwater volcano, the scale of the eruption suggests a more localized impact, but it still contributes to the ongoing global dialogue about volcanic activity and climate change. The environmental and ecological impacts of the sudden emergence of a new island from Japan's largest underwater volcano are multifaceted. From the potential for new ecosystems to emerge to concerns about environmental pollution and global climate effects, this event offers a unique case study. It highlights the intricate relationship between geological events and the environment. The eruption of Japan's largest underwater volcano brings into focus complex legal and geopolitical questions. The first issue is determining who has jurisdiction over this new land. In the case of Japan, the island's location within Japanese maritime boundaries makes it likely that Japan would have legal jurisdiction over it. This implies that any activities, whether scientific or commercial, on the island would fall under Japanese law. Ownership of new land can be a contentious issue, especially in regions with disputed territorial claims. However, in this case, the island's proximity to Japan and its emergence from a volcanic activity that's inherently linked to the Japanese geological landscape makes it a clear addition to Japan's territory. This can have tangible impacts on the country's maritime boundaries and exclusive economic zones, potentially expanding its rights over surrounding waters and resources. The Japanese government, in response to such events, is likely to take a cautious and scientifically informed approach. The initial focus would be on studying the island to understand its potential impact on the environment and its stability. This could involve sending scientific expeditions to the island, possibly in collaboration with international geological and environmental organizations. There would also be a need to develop policies to manage and protect the new land. This could include designating the island as a protected area, especially if it becomes a habitat for wildlife, and regulating access to preserve its ecological balance. The government would need to balance the island's scientific interest with environmental concerns, ensuring that any human activity does not harm its fragile ecosystem. From a strategic standpoint, the formation of a new island can have various implications. For Japan, an island emerging in a region like the Pacific Ring of Fire, known for its rich marine resources, could be strategically significant. It might offer new opportunities for scientific research, potentially leading to discoveries about marine life, geology, and even climate science. Moreover, in an era where maritime territories are increasingly valuable for their strategic position, the emergence of new land can alter regional dynamics. While this specific island is unlikely to become a flashpoint given its size and location, it still adds a new dimension to Japan's maritime landscape. The birth of a new island from Japan's largest underwater volcano is also a development with significant legal, political, and strategic implications. The Japanese government's response to this event will likely involve a mix of scientific study, environmental policy, and strategic consideration. As with any new land formation, it presents opportunities and challenges, requiring careful management to balance scientific curiosity, environmental protection, and geopolitical interests. In recent years, the monitoring of volcanic activities, especially underwater, has seen significant technological advancements. Today, scientists employ a variety of sophisticated tools to keep a watchful eye on volcanic activities. One of the key instruments in this arsenal is the seismometer, which detects and records the seismic waves generated by earthquakes and volcanic eruptions. These devices provide critical early warning signs of potential volcanic activity. Another vital tool is the use of satellites. They play a crucial role in monitoring volcanic activities from space, offering a wide range of data, including thermal imaging and topographical changes. This bird's-eye view is essential for observing remote or underwater volcanoes that are otherwise difficult to monitor. Additionally, oceanographic research vessels equipped with advanced sonar systems are used to map the ocean floor and detect changes that could indicate volcanic activities. These ships can also deploy remotely operated vehicles and autonomous underwater vehicles, which can dive to great depths to collect data and visuals of underwater volcanoes and their eruptions. The field of volcanology has made leaps in understanding underwater volcanoes, thanks to these technological advancements. One of the breakthroughs is the improved understanding of how magma behaves under the ocean's pressure. Researchers have discovered that the interaction between magma and seawater plays a critical role in the style and intensity of underwater eruptions. This understanding helps in predicting the formation of new islands and the potential hazards associated with these eruptions. Another significant advancement is in the study of hydrothermal vents and their ecosystems. These vents, often found near underwater volcanoes, host unique life forms that thrive in extreme conditions. Studying these ecosystems has not only expanded our knowledge of biology, but also provided insights into the chemical processes occurring during underwater volcanic eruptions. Moreover, scientists are now better able to study the aftereffects of underwater eruptions, such as the formation of new seabed topography and changes in marine habitats. This research is crucial for understanding the broader ecological impact of volcanic activities on ocean ecosystems. Predicting volcanic eruptions, especially underwater, remains a challenging task. However, with advancements in technology and research, scientists are gradually improving their ability to forecast these events. By analyzing patterns in seismic activity, gas emissions, and even slight deformations in the Earth's crust, researchers can assess the likelihood of an eruption. The development of more advanced computational models also plays a significant role in future predictions. These models can simulate various scenarios based on the data collected, providing a more comprehensive understanding of what triggers eruptions and how they might unfold. Despite these advancements, predicting the exact time and scale of an underwater volcanic eruption is still not precise. Volcanic systems are complex and can be influenced by a multitude of factors. However, the ongoing research and technological development in this field are promising. As technology continues to evolve, we can expect even more sophisticated monitoring systems and a deeper understanding of these fascinating geological phenomena. However, the new island born from Japan's largest underwater volcano faces the relentless forces of nature, which dictate its survival and longevity. Natural erosion and weathering are the primary agents in this narrative. Erosion, caused by ocean waves constantly pounding against the island's shores, gradually wears away the land. Weathering, including both physical breakdown and chemical alteration of rocks, further weakens the island's structure. These processes are particularly aggressive on new volcanic islands, where the land is initially loose and unstable. The composition of the island also plays a critical role in its vulnerability to erosion. Volcanic material, especially when fresh, can be quite fragile. As waves and weather incessantly batter the island, this material can easily crumble and be washed away. This erosion can be rapid, especially during storms or periods of high seas, potentially leading to significant changes in the island's size and shape within just a few years, or even months. The transience of volcanic islands is not a new phenomenon. History offers several examples. In Japan's own geological past, there have been instances of islands that emerged and then vanished. For example, an island that formed in 1904 near Japan due to a volcanic eruption eventually succumbed to the ocean's might, disappearing beneath the waves as the volcanic activity subsided and erosion took over. Globally, similar stories have unfolded. An island that emerged off the coast of Pakistan in 2013 following a seismic event was another transient geological feature. It was gradually eroded away by wave action, disappearing within a year. These instances underscore a fundamental truth about new islands: their existence is often fleeting, subject to the whims of natural forces. The ephemeral nature of these islands brings us to a broader philosophical reflection on the transience of natural phenomena. In a world where permanence is often sought after, these islands serve as a stark reminder of the temporary nature of many natural occurrences. They embody the concept of constant change, a core characteristic of our planet's geology. This impermanence is a fundamental aspect of Earth's ever-evolving landscape. Mountains rise and erode, rivers carve out canyons, then change course, and glaciers advance and retreat. The formation and disappearance of these islands are just another example of this ongoing cycle of creation and dissolution. In understanding and accepting the transience of these natural phenomena, there is an opportunity to appreciate the beauty and wonder of these fleeting moments.